Alright, we got more problems to go. Number 7. We have sine theta plus cosine theta square plus sine minus cosine square, forgot the theta, that equals to 2. Alright, so clearly the left hand side is more complicated. So we have left hand side, we copy this again, don't be lazy. Cosine square and then plus sine theta minus cosine theta square. Alright then, looks like the only thing we can do is fully expand the expression. So we expand the plus first, so we have sine square plus 2 sine cosine and then plus cosine square theta, and then we do the minus plus sine square theta minus 2 sine cosine and then plus cosine square theta. Okay, now let's do some cancellation. So clearly we are able to get rid of the plus and the minus, right? And then other than that, we do the fundamental identity. So this one, look, we have sine square plus cosine square. That gives me a 1, right? And then we have another sine square, another cosine square. So overall, we have 1 plus 1 equals to 2. So that is equal to the right-hand side, and then we do our signature move. The proof is done. Number 8. Number 8, we have secant 4 theta minus secant square theta that equals to tangent to the 4 theta plus tangent square theta. So this one, to me, they are equally complicated, but I decide to do the left-hand side. So we start with the left-hand side. We have secant to the 4th minus secant square. Alright, let's factor our secant square. So this will be a square minus 1, secant square minus 1. We use the fundamental identity. Secant square minus 1 is equals to tangent square, right? Because we start with a secant, our destination is we have to end up with tangent. So that tells me the next step is we have to get rid of the secant square. So for the secant square, I use the identity. Secant square is equals to tangent square minus 1. Again, keep the fundamental identity in your mind. Don't just every time you apply it, you go back to check the identity. That is too slow. Keep this in your mind. Just 3 identity. It's not that hard to memorize. And then we multiply tangent square. So expand that, you get to the right hand side. So we have tangent to the 4th plus tangent square. So now you can do your signature move, right hand side, and then double slash. The proof is done. So that is number 8. And then number 9, we have 1 minus cosine square divided by 1 plus sine square. Oh, actually no square. That is equals to sine. So this is clearly, we start on the left hand side. Copy the left hand side one more time. And then we have to break the fractions. So this, if you rewrite the cosine square, there is not much to do. This is 1 term. The left hand sides are 2 terms. So I have to rewrite the 1 as 1 plus sine divided by 1 plus sine. That is still equals to 1, right? But I would like to work with a common denominator. And then this is a cosine square. And then we do the magic. We have 1 minus cosine square. Actually, if you don't want to do that, let's just erase this for now. I will keep the sign. Cosine square theta. So we have sine square plus cosine square equals to 1. So let me finish the bottom. And then at this point, you have 1 minus cosine square that equals to sine square. Alright, so we have sine square theta minus sine theta divided by 1 plus sine, and then this we can factor our sine. So this is a sine minus 1 divided by Oh, actually, this is a plus, this is a plus, this is a plus, this is a plus. If that is a minus, we are not able to cancel the denominator. So I just figure out my own mistakes. And then we get rid of these two. So we left with sine theta. So that is the right hand side. And then you do your signature move. The proof is done. Okay. Moving on to number 10. So number 10, we have 1 plus tangent theta divided by 1 minus tangent theta. That is equals to cotangent theta plus 1, and then we have cotangent theta minus 1. The left hand side and the right hand side, if you pick the left hand side, to be honest, the tangent, you want to get to the cotangent, I think picking either side is fine. But to me, I would like to pick the right hand side because the cotangent to me is more complicated than the tangent. So we start with the right hand side. That is equals to cotangent theta plus 1 divided by cotangent theta minus 1. And then I use the reciprocal identity. I rewrite the cotangent as 1 divided by tangent. Alright, and then you get a common denominator on top and bottom, so that means you are going to work with a complex fraction, which is a fraction divided by a fraction. So common denominator on top, that is a tangent. So this will be a 1 plus tangent. And then the denominator, don't worry about the tangent. The tangent will be cancelled, 1 minus tangent. So we have top divided by bottom. I will show you the step anyway. I know many of you already figure out what that is. Divided by tangent. So when you multiply the reciprocal. So this will be tangent on top and then 1 minus tangent on bottom. And then you get rid of the tangent. So what do you see? I see that we just get to the right hand side. So 1 plus tangent divided by 1 minus tangent. So that is equals to the right hand side, and then the job is done. Okay. Moving on to number 11. So number 11, let's switch up the color, shall we? So number 11, we have secant theta divided by cosecant theta plus sine theta divided by cosine theta, that equals to 2 times tangent theta. Definitely pick the left hand side, so we pick the left hand side. So we have secant theta divided by cosecant, and then plus sine theta divided by cosine theta. Okay, looks like we have to get a common denominator then. So the common denominator, because I'm trying to combine two fractions into one, so the common denominator will be the CSC times cosine. So for the secant, I am looking for a cosine, right? So that will be a secant times cosine. And then plus the sine, I need a cosecant. And then you apply the inverse identity. The secant is 1 divided by cosine, so we can easily cancel those. And then we have sine times 1 divided by sine. And then do we have to do something for the denominator? Our destination is a tangent. There is no way that we can keep the cosecant and the cosine in there. Alright, so for the cosecant, let's do a 1 divided by sine and then times cosine. As you get more and more experience, you can pretty much see the answer. I can see the answer at this point. So this, we have a 1 plus 1 divided by a cotangent, right? Cosine divided by sine is cotangent. The cotangent is the same as 1 divided by tangent. So basically, we can flip the tangent back to the top. The answer is equals to 2 times tangent theta. That is equal to the right hand side, and then the job is done. Moving on to number 12. Let's switch color. Let's use green. Number 12. Wow, I like this color. Cosine theta divided by 1 minus tangent theta, and then plus sine theta divided by 1 plus cotangent theta, definitely more complicated compared to the right side. Okay, I am going to pick my left hand side, so that is cosine, and then 1 minus tangent, and then plus sine, divided by 1 minus, is that cotangent theta? And then we have to get a common denominator. So our common denominator is 1 minus tangent times 1 minus cotangent. And then the top we have cosine times 1 minus cotangent, and then plus the sine times 1 minus tangent. Okay. Alright, looks like we have one way to go. Fully expand everything to see if we can take another step further. Cosine times a cotangent, and then plus sine minus sine times tangent, divided by the common denominator. Let's don't, should I break the common denominator right now? Okay, I'm going to do it in here, so maybe I can save a step also. 1 minus cotangent minus tangent, and then plus tangent times cotangent. Oops, I see one thing right here. So the tangent plus cotangent is just equals to 1, right? Because cotangent is 1 divided by tangent. So therefore, we have this 1 plus that one. So we have a 2. Okay, going back to the problem. So that is equals to, I don't see that we can do something interesting. Cosine theta minus this will be a cosine divided by sine, so that will be a cosine squared divided by sine, and then plus sine minus this tangent is sine divided by sine, so that will be sine squared divided by cosine. And then the bottom we have 1 plus 1, which is a 2 minus cotangent minus tangent. I don't see a way to get to the right hand side. Okay, so that happens all the time. You pick up more complicated side and then you do whatever you can do, but somehow you are not able to reach to the right hand side. That's fine. This is not a mistake. Okay, do not erase this. I am going to try another method. Maybe another method will work. If that other method will not work, we will come back to see if there is something that we can do. All right, so I'm going to mark right here. Try another approach. Okay, we pick the left hand side one more time. So the left hand side is, we have a cosine theta divided by 1 minus tangent theta plus sine theta divided by 1 minus cotangent theta. Oh, of course, this, if you are able to get to the right hand side, just do it. Okay, so another way to do this is we rewrite the tangent and the cotangent. So we have a cosine and then 1 minus sine divided by cosine, and then plus sine, and then this is 1 minus cosine divided by sine. Okay, common denominator, I mean in downstairs. So we have a cosine, and then this is a cosine minus sine, and then plus we have a sine divided by, this is a sine minus cosine. Okay, so once the next step is we take the top divided by the reciprocal of the bottom, meaning that all we need to do is we flip the cosine and the sine to the top. So that gives me a cosine square theta and then this is a cosine minus sine, plus you have a sine square theta, and then you have a sine minus cosine. The reason I picked this problem is because some people might think that the denominators are the same. They are not. So let me change color really quick. Change to a red. This is not the same as this one. If you want them to be the same, you can just take a few steps. I am going to swap the position of cosine and sine. This is a technique that you have to think about when you do proof. And then you factor out the -1. So that will be cosine minus sine. And then I am going to put the -1 in here. So that becomes a minus. And then let's go back to the green. So this, we have cosine square, and then cosine minus sine, minus, now I have a common denominator. Cosine square minus sine square is not equal to 1, all right? Not equal to 1. That is not what that is not the identity. So cosine square minus sine square. Let's erase this for now. I'm going to use another color again. So for the cosine square minus a sine square, so think about this, x square minus y square. How do we factor that? That is x minus y times x plus y. Okay, so we're turning to green, not this green, I think it's this one. So we have cosine square minus sine, so that is a cosine theta minus sine theta times cosine theta plus sine theta, and then divided by, this is one common denominator, so cosine minus sine. What do you see? I can see that we can do a cancellation. So that's equals to cosine theta plus sine theta, which is exactly equals to the right hand side, and then the job is done. Number 13. Number 13, we have tangent minus cotangent divided by tangent theta plus cotangent theta, that equals to sine square theta minus cosine square theta. Let's make the screen a little bit bigger. Maybe that is easier for you to read. Definitely pick the left hand side. So starting on the left hand side, we have tangent minus cotangent divided by tangent plus cotangent. We write the tangent and cotangent as a fraction. And then this is cosine divided by sine. And then this is a sine divided by cosine, and then plus cosine divided by sine. And then we get a common denominator. Let's make this a little bit more bigger. So that is equal to, you have a cosine times a sine. So this will be a sine square minus cosine square, not equal to 1. And then the bottom, we have a cosine times sine. The top is a sine square plus cosine square. And then this is equals to 1, okay? This is equals to 1, but the one on top is not. Okay, so we have sine square minus cosine square divided by cosine times sine. And then one fraction divided by fraction is the same as one fraction times the reciprocal. And then this is a 1, right? And then we do a cancellation. So the cancellation is this and that. So we have sine square theta, I missed the theta over there, times cosine square theta, that is equals to your right hand side, and then the job is done. Number 14. Number 14, we have secant theta plus tangent theta divided by cotangent theta plus cosine theta. That is equals to tangent theta times secant theta. Left hand side, of course, that is secant theta plus tangent theta divided by cotangent theta plus cosine theta. Okay, let's put everything to fractions. That is sine divided by cosine, so we don't even need to find a common denominator. That is cosine divided by sine, and then plus cosine is just a cosine, or you can do cosine theta divided by 1 if you wish. The top is already in common denominator, so that is 1 plus sine divided by cosine, and then the bottom, that is a cosine. I want to get a common denominator, sine, so that will be cosine theta plus cosine times sine. And then we do the reciprocal thing. Multiply, reciprocal. Okay. Is there something that we can cancel? The answer is yes, right here. We can do a cancellation right there. I don't want to do a orange on orange. We can do a cancellation right there. What do we do? All you have to do is you factor out the cosine. So let's just erase this. So I don't need to write one more line. Go back to my pen. So we switch. We factor out the cosine, and then 1 plus sine theta, and then you can see that this 1 plus sine cancels with that, and then we have sine divided by cosine times cosine. Sine divided by cosine is a tangent, so basically we have a tangent, and then what else? This is a 1 divided by cosine, which is a secant. So that is equals to right hand side, so the proof is done. $15. Change color again, let's use purple. 15, so we have sine theta plus cosine theta divided by cosine theta, and then minus sine theta minus cosine theta divided by sine theta, so that is equals to secant theta minus cosecant theta. Alright, we pick the left hand side. Let's push this up. That is a sine plus cosine divided by cosine minus sine minus cosine divided by sine. Alright, I don't want to work with a common denominator. Let's break this down into a fraction. So the method that I am going to use is, remember this, a plus b divided by c, that is a over c plus b over c. A minus b divided by c, that is a divided by c minus b divided by c. When the top and bottom are switched, there is no way to break this fraction. Please remember. Okay, so we have a sine times a cosine, and then plus cosine divided by itself, and then minus sine divided by sine, and then this is a plus cosine divided by sine. Why? Why is this a plus? Because you are subtracting two fractions. That means there was a parenthesis. So after you distribute the minus, the second minus becomes a plus. Just imagine that you are subtracting these two once you distribute the minus, that becomes a plus. Okay, so this is should I just put that to tangent? I don't think so, because we don't have tangent on the right hand side. Okay, we keep the sine divided by cosine for now, and then plus 1 minus 1, okay, they are gone, and then plus cosine divided by sine. Okay, we don't have any cotangent or tangent on the right hand side, so I cannot just put that into tangent and cotangent. So that, other than that, the only thing we can do is we get a common denominator again, because we want to add those two fractions. And then sine times sine is sine square theta plus cosine square theta. Oh, the top is 1, so 1 divided by cosine and sine. Just like 1 times 1, right? It's the same as just a 1. 1 divided by cosine, 1 divided by sine, then you just get to your right hand side. So that is, take a look, the right hand side, secant. And then CSC. So that is equals to the right hand side. The job is done. So that is number 15. And then the last one is number 16. Number 16 has more works to do. Let's switch color again. Which color I haven't used. Let's use a blue, shall we? Number 16. We have a 2, wow, I love these colors. Square theta minus 1 square divided by cosine 4 theta minus sine 4 theta. That is equals to 1 minus 2 times sine square theta. Okay, definitely the left hand side. So we start with the left hand side. That is equals to 2 cosine square minus 1, and then cosine 4 minus sine to the 4th. Don't forget the square. Alright. Okay, this I tried two approach. The first approach I tried was I fully expand the square. However, there is nothing you can do if you go that way. Maybe you can get to the right hand side, but I did not work all the way to the end. The math was too complicated. So instead of doing that, I am going to do this. And this is the reason why I picked this problem. I'm going to do this. I'm going to rewrite the 1. So the 1 is equals to sine square plus cosine square theta. Alright, so you rewrite the 1, and then what do you get? So this, you have 2 cosine square theta, you minus this, right? So you are actually have sine square theta, not plus, minus cosine square theta. Once again, you are subtracting these two. So when you distribute the minus to the plus, that becomes a minus. The denominator that is equals to I factor it. So that is cosine square minus sine square, and then cosine square plus sine square. In case you are wondering why, this is, do you remember this? X squared minus y squared, that is x minus y times x plus y. Basic, right? In factors. If you have x to the 4th minus y to the 4th, then that is x to the square minus y square times x square plus y square. Okay, now back to this problem. We have 2 cosine. Look, we have 2 cosine. Subtract 1 cosine. They are all in square. So that means the top we have 2 minus 1 is 1, right? So we have cosine square minus sine square. Don't forget the square. And then the bottom, what do we have? The bottom we have cosine square minus sine square, and then times cosine square plus sine square. Do you see that these two, they are identical, cosine square, sine square, cosine square, sine square, but here is a second power. So that one thing that you can think of is, how about this? You have x squared divided by x times y. So basically that is equals to, you can reduce the power by 1, right? X divided by y. Okay, going back to this problem, then you have cosine square, forgot the theta, sine square theta divided by cosine square plus sine square. Okay, I'm not going to write another line. So this one I will just use a highlighter. This is equals to 1. So basically that is equals to 1. And then that's the leftover. We have cosine square minus sine square. Cosine square minus sine square. Is this our right hand side? Let's go back and take a look. The answer is no. The right hand side is 1 minus 2 sine square theta. Alright, so that means we have to do more rewrite. I have sine square, but this is a 1, so that means cosine is not allowed. I need to get rid of this guy. So cosine is 1 minus sine square. And then minus sine square, so you have a square minus a square. You have 1 minus 2 times sine square theta. That is our right hand side. Right hand side. So now the job is done. Okay, so that will be all in this lesson. I highly recommend you to go back to the very top of this video. Try to solve these problems by yourself. If you want to do it fast, you need more experience. Where do you get this experience? You have to practice. All right, I will see you all in the next lesson.